So I'm 1/3 of the CERN open hardware license drafting team, and Javier Serrano is here as well. Unfortunately, Miriam Ayers, who's the third member, isn't able to be with us today. So what is it? Well, it's a suite of licenses designed for open hardware. There was just one license. There are now 3. I will explain that in a moment. So it might be helpful just to recap a little bit and give you some history. So the original CERN Open Hardware License, version 1.0, was produced in March 2011, and then there have been subsequent versions. We then, towards a couple of years ago, we decided that some radical changes were needed. So we put a lot of effort into redrafting the license. And then we decided that although the redraft did what we wanted it to do from a legal perspective, it wasn't very elegant. So we basically ripped it up and started all over again. And now we have a beta 2, and it's really the beta 2 that I'm going to be talking about today. So what are we trying to achieve? Well, fundamentally, it's a copyleft for hardware. So it's supposed to have GPL-like effects as far as hardware designs are concerned. There is also now permissive variety, which I'll speak about later, but the main variants of the license are copyleft for hardware. And we're very conscious that the license needs to cover a broad range of hardware. So not just electronic devices, but also silicon at one extreme, mechanical devices at the other extreme, but even things like sculptures, artistic objects. The broader a range of physical objects that we can cover with this license, the better. We want to create a commons of hardware designs that make it easier to take various hardware designs and combine them with other hardware designs so that you're not constrained using just one silo of hardware designs. And we want to try to make it easy to understand. And I think of all of those, the last one has probably been the biggest challenge. So the problems that we identified from the first version of the license were, first of all, what's the scope of the copyleft? How far does the copyleft effect extend? Then people spoke to us a lot about compatibility with other licenses. People are using a variety of licenses in open hardware, GPL, BSD, MIT, and Apache, Solderpad. And the question is, how easy is it to combine designs that are licensed under one of these licenses with designs that are licensed under the CERN Open Hardware license? Another problem that we have, in contrast with the world of software, is that there are fewer open source tool chains available in hardware than there are in software. And this creates particular problems with ASICs, where there's a lot of proprietary tool chains that have a lot of proprietary libraries that you need to be able to create anything useful. So the question is, how do we deal with those? So FPGAs and ASICs have really been part of the a core focus in coming up with the new license to make sure that it actually addresses the practicalities of those particular forms of hardware. Number of other issues that we addressed. I'm not going to go through each of these in detail. I mean, we've borrowed a lot of terminology from other licenses that people will be familiar with, like GPL v3, so using the word convey, for example. We've tried to put some clauses in there to dissuade trolls by ensuring that it's a compliance-first approach that we're looking for rather than opportunity to try to gain damages for infringement. It has the 3 variants. There's a strong variant, a weak variant, and also a permissive variant. And it actually works quite well for software, we believe, as well. So let's talk about scope. Right. So this isn't a quote from the license. This is really just sort of explaining what it does. But the words that have got capital letters are defined terms within the license. So the idea is that if you make a product using covered source, you've got to make the complete source available to a recipient of the product, either privately or via a source location, and you've got to license the complete source under the CERN OHL. So the key to that is that these obligations only kick in once there's a recipient of the product. Until there's a recipient, if you're just doing everything internally, then although the license is there and it's allowing you to do all of these things, none of your reciprocity obligations kick in until a recipient actually receives the product. So what do we mean by complete source? Well, it includes not only the design materials themselves, but it includes any interfacing information as well that relates to that. So when you've got complete source, this is quite like the concept in GPL v3, where the complete corresponding source is not just the source code, but it also has to be source code that is in preferred forms. It's got to be documented ideally, but it also needs all the interfacing information and all the other information that you would need to be able to make a product using that source. It doesn't include something that we call available components. So if you have a piece of hardware design and you've created the source for that, and I'll go into a little bit more detail about what that means later, but you only need to provide the source for things unless they're available components. So let's talk about the hierarchy of different hardware designs. So let's start with the circuit board. This is the sort of classic example of a hardware design. Then on the circuit board, you will have components, and those components are things like resistors, capacitors, inductors, and so on. They also may include things like FPGAs, ASICs. An FPGA requires a bit stream, which is also a component. And then, in order to create the bit stream, you're going to need some custom code that you've written, some standard libraries, some third-party libraries. And then if you go further up the hierarchy, that circuit board may find itself in an enclosure connected to a power supply unit together with some other circuit boards. And that enclosure may find itself in a rack. And that's got network connections and power cabling and so on and so forth. And then that rack may find itself in a data center. So it's possible to have a hierarchy of different objects. Each of those things is capable of being licensed under the CERN Open Hardware license. And everything below a particular level of hierarchy is capable of being determined to be a component, potentially an available component. And each one of those items is a product. So what we're encouraging now is the idea that if we have different sort of layers of abstraction of design, then if the circuit board is itself licensed under the CERN Open Hardware license, then also some of those individual components, either they're available components because they're very, very easy to get hold of, like resistors, capacitors, etc. But they may be things that you've custom designed for that board, like FPGAs, and those FPGAs are regarded as being a separate product, which are themselves potentially licensable under the CERN OHL. And so what we've tried to do here is to really reflect the realities of hardware design, rather than saying everything in this box is licensed under CERN OHL, which causes some philosophical and practical difficulties. So what do we mean by an available component? Well, an available component can be something that is itself available under the CERN OHL or a compatible license, or it can be something that's available with the specifications, characteristics, and interface information necessary to make the product. So sort of very basically, a resistor can be an available component because it's something that you can acquire very easily, but you need to know, obviously, what the resistance is. You need to know what the physical size of it is. You need to know what sort of connections that it has, whether it's surface mounted or whether it's sort of through hole. What the power rating is, what the tolerance is, and so on and so forth. So you've got to provide all the necessary specifications. And you've also got to enable somebody to be able to source it as well. Now, key point here is that obviously resistors aren't free. Available components are things that people will have to purchase, or may have to purchase. And also to reflect just the realities of the way that hardware design operates. If something is part of the normal distribution of the tool chain, so if there are some libraries that come along with the tool chain, then they're also to be regarded as available components. And again, it's acknowledged those are things that you will probably have to pay for. So what do we mean by a product? Well, it could be a finished product. It could be the circuit board that has got everything on it and it works. But it also could be an individual component within that product. And it could be an intermediate form, which is derived from the complete source. So in computing terms, if you've got a C program and then you compile that into an object file before it's then linked into the executable, then that object file itself would be regarded as being a product. And in the same way, from a hardware perspective, sort of intermediate files that are then processed to create your ASIC design, for example, they would also be regarded as a product themselves. So what we've done is we've constrained the notion of copyleft so that it's constrained upwards by the concept of a product. So it doesn't mean that if you take a CERN open hardware licensed FPGA and you put it on a circuit board, that the whole of that circuit board then also has to be released on the CERN open hardware license. So, so once you've created a product, that really defines where the boundary of the copyleft stops from an upwards perspective. And from a downwards perspective, the scope of the copyleft is determined by whether there's an available component or not. So if your design consists entirely of some custom code plus some available components, none of those available components, you don't have to release the source of this. You don't have to release the recipe for making the resistor. That's not something that you're required to do because a resistor is an available component. And this is where it gets sort of a little bit conceptually complicated. What is the difference between the strong and the weak copyleft versions that we've drafted? Well, with the weak version, you can release a product without releasing the code for all of its components if you have all of the interfacing information, etc., for all of those components. So in that way, it works a little bit like the LGPL, but upside down. Strong is different because this concept only applies to physical components. So if you've got digital components, if you're talking about, for example, a sort of processor core HDL, then it means that all of the other code, apart from the system libraries, etc., but all of the other code would have to be released. So there's a distinction between the two. And what's the logic behind this? Well, we acknowledge that physical components will generally have to be purchased. And in the same way, it's not going to be the case that you will have the design files available to make those physical components from atoms. Whereas it is, in theory, possible that if you want to go for the strong variant of the CERN OHL, you would be able to get hold of all of the design files for all of the HDL for a particular processor core. And then that would mean that the whole of that ASIC would then have to be released under CERN OHL. Permissive version is really just there to complete the family. It's a lot simpler than the reciprocal versions. It's got the same patent provisions in that the rest of the CERN OHL does. And it works in a way that's very similar to Apache in that you have to retain all the notice files, etc. But obviously, you don't have to release the source because it is a permissive license. Sort of a couple of questions that we've been asked about this. So why don't we allow an option in there to automatically relicense under GPL? And this is a question that we've been asked a number of times. And there are some other licenses out like MPL, for example, in the software world that allow re-release under GPL. The logic behind that is that, I suppose that the most important one is there's a distinction between the two licenses. And in some ways, the GPL is stronger because it really does go all of the way down. It doesn't have this concept of available components in there. So that would mean that if you relicense something under GPL, you would have to provide the code to pretty much everything that you've got. So that strengthens it. But on the other hand, GPL is in some ways a lot weaker because there are some provisions that we've put in the CERN OHL that the GPL doesn't have, such that it's possible to put a requirement for a source location in a notice attached to a CERN OHL licensed file, and then that has to be preserved. And the source location can be placed potentially on the item itself. So if it's a chip, there might be a requirement to actually stamp something like a short URL on the actual packaging of the chip itself, or if it's something else, it could be just in the actual cardboard box that it comes in, or whatever. But there is this requirement to keep a source location in there. And if you really want to have the ability for something to be relicensed under the GPL, then we suggest that you just dual license the project in the first place. It also would potentially be unfair for people who have already licensed under previous versions of the CERN OHL, who didn't anticipate that their designs were going to be released under the GPL, to suddenly say, this is the new version of the CERN OHL, oh, and by the way, you can pretend that it's GPL as well. So that was the reason that we didn't do that. In terms of compatibility with other licenses, so permissive licenses in general, BSD, MIT, Apache, Solderpad, they're all permissive licenses. They're automatically compatible with the CERN OHL because you can relicense any code that has been licensed under any of those licenses under CERN OHL itself anyway. So that falls within the definition of available component. That's fine. For GPL and LGPL, this is more problematic, and it's not a problem that we can really solve. We tried, in the previous beta version, we tried to solve it by saying, okay, here are some additional permissions that you can attach to your GPL licensed designs that will make them compatible. But the problem with that is, of course, you've got to persuade the original copyright rights holder in those particular designs to use that particular exception in the first place. So it seemed it sort of got terribly, terribly complicated. I mean, from a CERN OHL perspective, there is no problem with having components as available components that are licensed under those licenses. But the problem is that they have the effect from their perspective. You can't comply with the license of those components at the same time as combining with CERN OHL unless you have an exception. So either we would hope that the industry would recognize that compatibility was a good thing and say, yeah, I'm quite happy for my GPL license design to be able to be combined with CERN OHL design and therefore allow an exception, or ideally just dual license. I mean, that would be the best way to do it. So in these cases, I think dual licensing tends to be a much more practical way of dealing with this particular issue. So where are we going to next? The licenses themselves, there's a sort of ever-growing FAQ. We've had some really fantastic responses from people to the inquiry. They've sort of asked some really searching questions, and as a result, we've made a few tweaks to the beta version of the license. So we've got the link to all of that there. So I encourage everyone, please do go and have a look and then engage with us if you've got any particular queries about how the licenses work. We've been consulting with a number of other bodies as well, so FOSSI Foundation, SPDX being two of the most prominent ones, and they've provided some sort of really useful, helpful feedback to us. And probably the easy way to comment, feel free to get in touch with me if you want to ask me any questions, and then the sort of core licensing team, we sort of regularly pass these comments amongst ourselves. It's helpful, if it's okay, if you do send me comments, it's helpful for you to say that you're happy for the comments to be made public. I mean, we will respond privately, but it's a lot easier if we can just create, we've got a wiki page that's got various questions and answers on there, and it just benefits everyone if you're happy for those to be made public and our responses to them as well. I put any questions down here. I'm not sure we've actually got time for anything. There's a sort of round table forum later on, but so we do have we got time for a question? Yeah, okay, great. One question. Thank you very much.
Thank you very much. Questions? Just wait a second. Sorry.
Sorry, do you want to?
Thank you. So on your previous slide, you had, compatibility with other licenses. So BSD, MIT, Apache, and so on. Are you talking about compatibility from downwards or compatibility upwards? Because those are very different, right? So if
yes, they are. Yes, yes. So if you you can freely use components licensed on any of those permissive licenses as components within a CERN OHL design. And because basically what you're doing in those circumstances is you're likely effectively to be relicensing them under CERN OHL is essentially what's happening. But if you're saying, can I take an Apache design and put CERN OHL components in it and then release the whole lot under Apache? Nah.
Okay, that answered to my question. I got, sorry, a follow-up on that. What about, you talk about available components.
Yes.
Where this could be resistor, capacitor, things that are not effectively open source, if you want.
Yes,
Have you thought about the case where you have components that are not technically under an open source license, but they are available in the same way as resistors, so you can get it cheaper or for free? That could be IP components that are not open source,
right,
but they are freely obtainable anywhere.
Yes, yes. So I think we just have to accept the realities of the world in that, unfortunately, to create a lot of functional hardware, you're going to have to engage, with the proprietary world, and that is going to mean that you're going to have to potentially purchase some libraries. So the idea is we want to, at least if anything, we want to try to avoid discrimination. So the idea that somebody can say, okay, only you can have this particular component under that specific license and nobody else can, then that will basically ruin the whole CERN OHL design for anyone else. If, on the other hand, you can make this particular chip because you're using a particular custom library that you've got from one of the chip foundries, and as long as other people are able to get it, even if they have to potentially pay quite a lot of money for it, then that's something that can potentially be released under CERN OHL. Yeah.
Yeah, my question, I think, somewhat related. If you've licensed something like a RAM under a commercial license, could you put stuff under this CERN license on the same chip? I mean, does that count as a physical component in your definition?
Yeah, I think Javier's keen to respond to that one.
I think we've been talking about the license as if it were kind of mostly the copyleft variant, but it's very important in answering these questions to know which one of the three variants of the license we are referring to. We have a strong copyleft or a strong reciprocal, weak reciprocal, and permissive. For your question, in the case of weak reciprocal and permissive, there would be no problem. If the CERN OHL license that you're intending to use for the top level or for any of the components is the strong reciprocal, then there would be a problem with it. So it's very important when you try to figure out if CERN OHL would work for you to have one of the three variants in mind, because this is one of the big new things in version 2 of the license. We have three variants. So yes, permissive is what everybody would expect. Very similar to Apache, but with the anti-troll clause and a number of improvements. Weak copyleft is if you modify the CERN OHL part, then you should release your changes, but you don't need to release the rest of the design. And strong copyleft is we want it all.
Okay. We have another question.
Yeah, have you considered assigning codes to all the different license types so that if you were to query a system through SPI or I2C, you could say, get back the information about which license it is?
Yes, so we've engaged with SPDX to do that. So each of the variants has an SPDX identifier, short tag, which you can use in your code to identify which license applies.
Which then needs to be standardized the way of querying, right?